Hello, it's Tony back with you again. This is a smart home I did. It's in Dublin, Ireland, and I did this project, I'd say 3, maybe 4 years ago. So it's good and old. It doesn't look old. It's a fully kitted out smart home with obviously 65-inch OLED screens and music and lighting, all of this type of thing. I'll switch over to the camera, the other side, and show you what we've got here. Okay, as we walk through, I'm not going to show you too much because I didn't ask for permission to film this house. Just the discrete little snippets. Everything's custom made here, fully concrete finished walls, Suco finishes, and dim to warm lighting, all of that sort of thing. But I won't show you the inside of the house. I didn't ask permission. Our problem is outside. Now the gardener, the gardening contractor, I won't show you the cars, decided to do the garden lights themselves. So we have these real cheap, we call them robust GU10 lights here. They're scattered around the place and they're tripping off the whole. There's probably about 50 or 60 of them here, and every single one of them has a little junction box just buried in the ground, which is susceptible to water leaking in. That's the type of thing there. It's not the way I would do it. It is armoured cable, but they haven't used the proper gland, and it is probably filled with gel because that's what they had to do to stop it from dripping. But I like to put my cables 300mm up on a post, my boxes, and then run a solid cable over to my lights. It's the way it works for me. Apologies, interrupted by a call there. So this garden here is a beautiful house, beautiful period property. Everything's great except the garden lights are constantly tripping the RCDs. RCBO I should say. Now for the driveway here, it's a lovely big driveway with plenty of space. I won't show you the cars, they're behind me, but we have these robust bollard lights, and as you can see this one's fallen over, so I don't know what's going on there. I think probably got knocked by a car reversing, and then this one is all crooked as well. So what I'm here to show you today is my solution for getting over this RCD tripping scenario. It's raining here at the moment, but I'll try to show you. We have these brand new SIM lights now, bollard lights, which are much shorter and less susceptible to being knocked. They have a really rugged steel finish, and they're finished in the favourite colour of the client as well. So it all makes sense for this. But the magic behind these are that they are 24 volts DC. So instead of these 21, I think, 21 or so bollard lights scattered all over the place, we're going to just install some of these transformers, 24 volt transformers. Over there, back by the bins, by the gates, there is a big knockout box, and I have an armoured cable running off 3 parallel runs to the bollard lighting circuits in the 3 different locations. So these 24 volt cables can do 60 watts, and these are 3.6 watts each. So we do the maths, we split it up into 3, and we've got plenty without getting the transformers too hot. So here's where I've started. I've only got up to this stage here, as you can see all my tools, and this is the replacement. Now that's how the new ones are going to look. 1, 2, 3. So 21 in total to do. So what I'll do is I'll get back to you when I have them working, and we'll see how they work and if they trip the fuse. Okay, I'm just going to cut back in 2 little pieces of advice to share with you here. I just took this last one off on the row of lights, and just to say, one really good thing you can do in these situations is, you see this black Copex sleeve, and this is 20mm, it's called M16 for some reason. This is a black sticky kind of rubbery type of Copex, and you should sleeve your existing cable. Now that wasn't sleeved, I've just cut this and I've just literally pushed it in there. Now the reason why we sleeve it is like it's more visible for the gardeners if they're digging, and it's also, it's only, it doesn't need the earth, this is only going to be down rated to SELV now. It's literally 24 volts. But the reason we sleeve it mostly is because of this kind of garden, this type of property, large kind of garden. You have trouble with foxes. Now the foxes tend to chew through cables, and they like to try to drag lights off of them and all sorts of things like that, but they hate the taste of this black rubbery Copex. The other thing here also is, I don't know if you can still see it, but there's thousands and thousands of ants on this particular light that I've just removed. And anyway, I've thrown that one in the bin now, it's gone, it's off. The new one is not going in until we treat this ant's nest that's obviously there. Now the reason why, and why I'm telling you this, is because the ants will find a way, no matter how much silicone you put around these holes here, these cable inlets and screw inlets, they'll find a way up into that light fitting, and they kind of pull earth up with them to make to extend their home, their nest, and that earth then gets damp as the water rises, and it shorts out the electrical supply. Whereas we won't have that many problems now that it's 24 volts, but when it's 230 volts, you have huge tripping problems with ants that have climbed up into these bollard light fittings. Always watch out for ants and bollards. Okay, so well, half the job's done, and they actually look quite nice, except it's really bright sunshine now. It's always either raining or the sun is shining where we are. As you can see, they both look very effective. So we're about halfway there to be done. So that's a typical example of how to get over RCBO's tripping by converting lights to 24 volt. Thank you very much for your time.